Matrix algebra is foundational to data science and machine learning as it enables efficient manipulation and transformation of large dataset. Matrices facilitates various operations like linear transformations, eigenvalue decomposition, and singular value decomposition, crucial for algorithms like principal component analysis and recommendation system. Understanding matrix algebra is essential for developing, optimizing, and interpreting complex machine learning models, making it a fundamental tool for data scientists and machine learning practitioners. In this lecture, we are going to cover fundamentals of matrix algebra with Python using Colab. This is my desktop. You can see here. This is my desktop, and two things are very important which I going to discuss here. For the matrix algebra, we will use SymPy live shell as well as collaboratory Google Colab. Okay, so first you can see this is the live.sympy.org, SymPy live shell, and we can do all the basic operations on matrix. See how we can create a matrix in live shell, and the same syntax will be used in the collaboratory or in the Python. Syntax will remain same because this SymPy live shell is based on Python. See here, to enter the matrix, first we need to use this very statement. We need to import from SymPy, import the this operation. By using, we can easily import and all the basic operations which are required for mathematical computing. And after that, we can use to have the input for the matrix. Suppose that I have m is equal to matrix is inbuilt function in SymPy library. And if you want to enter any row matrix, then you will enter 1, 2, 3, and this will return a row matrix. And also we need to print, then again to print this matrix, we have to use this assignment variable m. So in the very first statement, the information we enter in the statement stored in m assignment variable, and if you want to print, then again enter m and control m. By using control shift m, the statement has been entered and we have returned the column matrix. If you want to enter here for the row matrix, how you can have the row matrix? You have to use this bracket on left side and on the right side, then you have the row matrix. Okay, and enter. See, now we have a row matrix m is equal to 1, 2, 3. So these are two very simple examples how we can enter column matrix and how we can enter row matrix. Okay, now if you have multiple rows in the matrix, so you can enter here by using comma. So this is the element of matrix. These are the row element. Okay, and if you want to enter second row, then use again this bracket, and I have the element 3, 4, 5, and again one more row you can do by using this bracket 5, 6, 7. Now this is, we have a matrix of 3 by 3 order. Control just enter here, and you can see that this is the first row element, these are the second row element, and these are third row element. So in this way you can easily create a matrix in the SymPy live shell. If you want to use collaboratory Google Colab, then you need to enter in Google Chrome. Here is Colab notebook. Okay, we are using Colab notebook, enter, and on the top you can see here Google Colab. When you will enter and select new notebook on left side, press this one. This will take a few seconds to open, and you can see that notebook has been opened. At this place you can rename it. This is my first matrix notebook. Okay, I save this with the name, and the most important thing that the information which you will enter at this place will save automatically in Google Drive. And if you want to enter here title for the same, you can easily do here. I am using here hash for the big size or the font size of the text. This is matrix algebra. This is matrix algebra, and then control shift and enter. If you want to shift this statement on the top by using this upward arrow sign, you can shift on the top. See here, select it, and then again, now this is the title of this part. Okay, all the statement will run at this place. Here we can enter the code. So first we need to import from SymPy import, and then shift and enter, control and enter, sorry. So when you will enter here control and enter, the statement has been run, and if you want to enter one more statement, then only enter. Here we can enter the more statement like m is equal to I have matrix, and here is any matrix having the element 2, 3, 4. Then I have again when you will run this one, and also you want to print, then enter and m. So this will print the statement. And if you want to run and you need the outcome of this statement, then control and enter. So when you will control and enter, we have the matrix. And the most important thing that you can edit at this place. Okay, use this bracket, and on the right hand side also this will return we have row matrix, and if you want to enter some more rows, use again the bracket, and these are the element 4, 5, 6. Then I have one more row, and the element of the third row we have is 5, 7, 9. And when you will execute this statement by pressing control then enter, and you will find that we have the matrix of 3 by 3 order. If you will shift and enter, you will have the output as well as new shell will also open. Here you can enter one more matrix. N is equal to, we have is the matrix. First we have to choose here matrix, then this bracket and close it. Then we have the row element 2, 3, 7, and the second row we have is, we have to use this bracket also. Then we can enter the multiple rows. Okay, keep this syntax very carefully, note all this. Then we have 4, 6, 9, and again we have one more row. Then you can enter here 3, 5, 6 and control and enter. The code has been done, but store in n. If you want to print this one, then enter and enter at its place n, then control and enter. This will print the value of this matrix, and you can find a new matrix has been entered. So the information which we are doing update in this file will be saved automatically in your Google Drive. And on the right hand side you can see here RAM and disk size which is used at this place. RAM is 1.34 GB and out of 12.68 GB, and you can see here the space, disk space we have is 172 GB and 26.26 GB is used. Okay, now the most important thing here is if you want to check these files, you can go to your Google Drive. You can see this is the Google Drive, and in the Google Drive, yes, so this is the matrix IPy NB lab. This is the matrix notebook. This is matrix algebra and basic. So all the files which I operate will be saved in your Google Drive automatically, and if you want to create any folder, you can save these files in the folder also. Okay, and here we have Colab notebook. When you will the Colab notebook folder is also created. When you will double click on it, yeah, all the file which I have created are in the Colab notebook folder. You can find here, and all these files will be saved automatically in your Google Drive, and you can use these files in future anytime, and you can share these files. You can work in the group also. So this is the beauty of this Colab notebook. I am closing these files. Okay. So all the entire content which I want to cover in this lecture has been created, and by using the same content which I develop for you, I am using here so that in the minimum time I can present all the entire content, so that in the minimum time we can cover all the required content. So here you can find the same statement. On the very top we have the from SymPy import, and we have the matrix of 3 by 2 order. Okay, and again I have the column matrix. When you will execute this from this place, and the syntax you can observe from this place very carefully, which are very quite simple, and simply you can enter. Again we have the matrix, which is at this place we have two matrices. One is M is equal to, we have 3 by 2 order, and the element of the first row we have is this is the first row 1 2 3, and this is the second row of the matrix. The element are 3 2 1, and n element have this row, and the element are 0 1 1. Okay, this is row matrix, sorry, column matrix. So now we can multiply M matrix with n, and when you will execute, this is the product of these two matrix, and the syntax for the multiplication we have is this product sign. Also, by using shape function in the SymPy, we can find the order of the matrix. First we need to import from SymPy import shape, and by using this function we can easily find out the order of the matrix. First we need to execute, we need to import this shape function, then we can use at this place. So here you can see this is the play sign, and when you will play, the code will execute, and now you can execute this code also. The above function is used at this place, so first you need to execute the above statement, only then this statement will work, because this is a new function which we need to use at this place. So you can see that the order of this matrix is 2 by 3. So there are 2 rows, okay, and 3 columns. If you want to access any row or column, you can do at this place. Okay, to extract any row or column, we will use m dot row, and for the column we are using m dot column. Okay, these are 2 functions, and by using you can extract any row and column. See at this place very carefully when we will execute this statement, and you can find here we have this matrix of 3 by 4 order. Okay, and I am using here m dot row minus 3. This is the last third row. Okay, this will return last third row, means first row. See, when I will execute, the above first row has been returned at this place. If I am using here minus 1, then this will be the last row. Okay, this is the last row. The element of last row is 4 5 6 7, and here are the same. If you are using here is 0, 0 means first row. Okay, so see here m dot row, 0th is first row, and in Python the numbers are starting from 0 1 2 3 and so on. 0 means first, and 1 means 2. If you are using here 1, then this will return the second row. Note this point very carefully. Yes, so this is the second row, and if you are using here is 2, then this will return third row, and if you are using here 3, then see what happened. Here is error, because the matrix don't have 4th row. That's why we have the error message. So note these syntax and how we can use. If you have the 1 at this place, this will return the second row. Similarly, you can extract the columns of the matrix, and you can find here m dot column. M dot column will return the matrix second. This will return the third column. Okay, this will extract the third column, and if you are using here 3, this will return the 4th column, and the element of the 4th column we have is, you can maximize the size by pressing F11. Okay, so you can see here the 4th column element are 5 6 7, and if you are using here minus 1, By using -1, you can have the last column also, and the element are 5, 6, 7, and if I am using here 2, so this is the second last column, and see here the element are 4, 5, 6. Okay, so in this way you can use to extract any row and column. If you want to delete or insert any row and column, then we can do also. If you want to delete any row and column, then we will use this function row underscore del. So this will delete the row of the matrix, and if you are using column underscore del, this will delete the column of the matrix. See here how we can use. We have this matrix, and matrix is of 3 by 4 order we are using here, and I want to delete row element. I want to delete here row. Okay, I will use this statement m dot row del, and suppose that I want to delete the last row. I am using -1. So this statement will remove the last row. See here, execute the statement. First row is 2, 3, 4, 5, and second is 3, 4, 5, 6. These two are in the matrix, but last row is deleted. Again, if you will execute, and note that the matrix M is now have the element these 2, 3, 4, 5 and 3, 4, 5, 6. Only 2 rows are there. Once again, if you will execute, this will remove the second row also, and again when you will execute, this will return empty matrix. Okay, so first you need to, if you want to remove from this matrix, first you need to update the matrix, and only then you can remove the corresponding row or column. Okay, if I want to remove from first row, then what I have to do? First I need to update the matrix. This is 3 by 3, 3 by 4 order, and I have to execute this statement, and this will remove the first row. You can see the first row has been deleted from the matrix M, and the new M matrix we have only 2 rows, second and third from the given matrix. Similarly, you can use for the column to delete column. Here we replace COL, and this will delete first column from the matrix. First we need to update the matrix, then you will execute, and you will check that first column has been deleted from the above matrix. So according to the above discussion, you can delete any column, any row from the matrix by using this statement. Next, we have very interesting operation, and if you want to insert any row and column, then you will use these two functions. By using this function, you can insert a row in the matrix, and by using this statement, this function, you can insert column in the matrix. But note, when you want to insert any row and any column, note this statement very carefully. We have this M matrix, okay, and I want to insert in this matrix a row at the second place or the third place. See here, I have this new statement M dot row underscore insert. By using this statement, we can insert any row, and this is the row matrix. Okay, this is the row matrix, and we want to merge this row matrix in the above matrix, and the element are 2, 3, 4. Here I am using 2. So this row will be inserted at the third place. This will be the third row. See here. So the new row is inserted at the below of the 2. If you want to insert this row at the second, then I have to put at this place 1. So at the second position, this will be the second row in the above matrix. See, yes, these are the element at the second row, and second row become third. If you want to insert at the first place, okay, first you need to update, then execute. Now this element will be in the first row, 2, 3, 4, and first row and second row in the given matrix are now second and third row. In the same way, you can insert the columns also. So first you need to update the given matrix. See here, we have M dot column insert to matrix 2, 3, 4. So you have to see that at this place we have column matrix, okay, and this column we can insert anywhere by using the same statement. Just we have column, okay. When you will execute this statement, and you will see that this 2 3 4 has been inserted in the above matrix at the second column, third column, okay. This is the 2 number, it means this will be third column, and the element has been inserted 2 3 4 in the above matrix. Now there are some basic operations in the matrix which we can operate and are highly required for different type of requirement for the data science, for machine learning, deep learning, okay. So here we have the addition, then we have multiplication, power. These are just by using these symbols. This will be used for addition, this sign is used for multiplication, and double product is used for exponent. And if you want to take the inverse of the matrix, then you will raise the power -1, okay. See here how we can operate all these. And first you can see here we have two matrices, M and N, both have same order, okay, and M plus N will return us addition of these two matrices, because when you think to add two matrices, then order must be equal. Only then addition of the matrix will be possible. And execute this statement, you will find that we have new matrix addition of after adding these two matrices M and N, we have 1 6 7 minus 2 10 11. These are the corresponding element of the above statement. Similarly, you can multiply the two matrices, and if you want to product two matrices M with N, then the condition must be justified for the product, as you know when the product of two matrices will be possible. So the number of columns in M matrix must be equal to the number of rows of N, okay. Only then the M product of M with N will be possible. So when you will execute, and you can see that this is the product of M with N. Again, the scalar multiplication is also possible. M is the matrix, and we want to multiply this matrix with 3. And when you will execute, you will find that all the element of this matrix are multiplied with 3. So this row becomes 3 9 12, and the second row become -6 9 18, and third row element becomes 6 3 and 9. Again, if you want exponent of the square matrix, this is also possible by using this product sign. If you are using 2 times, then this is the 3 is exponent of M. So when you will execute this statement, this will return the cube of M matrix. If here is 2, then this is the square of the matrix, and if here is 4, then we have the corresponding matrix. If you want to find out the inverse matrix of a given matrix, this is also very quite simple. This is the M matrix, and the having element 1 3 4 minus 2 3 6 2 1 3, and the inverse matrix is defined as M double product -1. This is the inverse of M matrix, okay. So when you will execute, we will get the inverse matrix of the given matrix, and these are the corresponding element. And if you want to find out transpose matrix, this is also very quite simple, and for the transpose we will use here T, and by using this T function we can get the inverse of the matrix. Here is M matrix, and the element of this matrix are 1 3 4 minus 2 3 4 6 2 1 3. So when you will execute, we will have the M matrix, and if you wanted to take the transpose of the above matrix, then we will use this statement M dot T. T is used for transpose, and M is the given matrix, okay. So just execute this statement, and you will get the transpose, and in the transpose the rows element are in the column. So first row is first column, second row is second column, third row is third column. Again, if we have some important matrices like identity matrix, zeros matrix, ones matrix, these also can be created, and simple functions are there. If you want to create identity matrix, then we will use I function, and by using I we have a matrix n by n order. See, here is example. If you are using here 2, this will return the identity matrix of 2 by 2 order. See, if you are using here 3, this will return the identity matrix of 3 by 3 order. And if you are using at its place 5, this will return identity matrix of 5 by 5 order. So by using any number you can create identity matrix of the required. If you want to create zero matrix, and in the zero matrix of any order all the element will be zero. So here by using zeros function we can create here zero matrix of 3 by 4 order. See, so this is a 3 by 4 order zero matrix. If you want to establish a matrix of 3 by 2 order, then execute this statement and you can see this is the 3 by 2 order matrix. And if you need the square matrix 3 by 3 order, then we have to change the element and this will return square matrix. Similarly, by using the ones function we have a matrix having all the element 1, and by using ones you can see we have 4 by 4 order matrix and each all the elements are 1. If you have at its place 2, and this will return the matrix of 2 by 3rd order. See, so this is the 2 by 3 order matrix. If you want to create a diagonal element or diagonal element are given, then you can create a matrix by using diag function. This function is used for diagonal matrix, and by using the same, if you are given diagonal element you can have the diagonal matrix. See here, suppose that we have the diagonal element of matrix R1 2 3, and when you will use this diagonal function, this will return a matrix of 3 by 3 order. Execute and you will see that all the element of this diagonal element are 1 2 3. Sometimes we can create a diagonal matrix having diagonal element is matrix or row matrix or column matrix. See, in this example we are using here a diagonal function and this is the first element, and then after we have a 2 by 2 1 matrix, and then we have a matrix column matrix. Okay, and when you will execute, see the matrix here, you can see that the first element, this is the diagonal matrix including one matrix and column matrix. The first element is -1, and then we have the 2 by 2 order matrix and the element are 1 1 1. Then we have matrix column matrix at the last place and the element are 5 7 5. If you have at its place I, you are using here I, so this will return at its place we have 1 0 0 1 identity matrix. And if you will add here row matrix, see the change in the matrix you can do just by changing. Now we have this is row matrix. Okay, execute and you will find that this is the new matrix. So the here is -1 is the first element, then we have identity matrix, and then we have at the last we have row matrix at its place has been added. Okay, determinant of the matrix is also very quite simple by using m.det. Det is inbuilt function in the Python which is used for the determinant of a square matrix. Here we have a matrix and the element are 1 0 1 2 -1 3 and 4 3 2. This is 3 by 3 order matrix, and by using this statement we can easily find the determinant of the above matrix, which is -1. Now we have reduced row echelon form. This is also very important. Sometimes we need to reduce the given matrix in the reduced row echelon form, and the function is RREF. This function is reduced which will return tuples of 2 elements. The first is the reduced row echelon form, and the second is the tuple of indices of the pivot column. Okay, see here we have this M matrix, and the element of this matrix are 1 0 1 3 2 3 4 7 and -1 -3 -3 and 4. When you will execute, this will return the these are the 3 rows of the matrix in the echelon form, and these are the pivot you can see here. If you want to execute this statement in the SymPy, you can easily copy from this place, and then this is the SymPy. Okay, and come back. Then we are using this statement and enter this statement. You can see this is the first we have the echelon form matrix, and the second indices we have the pivot of the matrix. So in this way you can check the row reduced matrix as well as pivot of the matrix. If you want to find out the eigenvalues, eigenvectors and diagonalization, this is also possible. possible by using some syntax in the Python. So for to find eigenvalues of the matrix, we will use eigenvalues. This function will be used for the eigenvalues, and eigenvalues return a dictionary of the eigenvalues, algebraic multiplicity pairs. See how this will appear. You can see we have, this is the M matrix at this place, and this will print the matrix. Then after we are using this statement for the eigenvalues. When you will execute this statement, you will see that 3, -2 and 5, these are the eigenvalues with algebraic multiplicity pair. So the meaning of this one is 3 is one eigenvalue, the -2 is also one value, and 5 is 2 times. So 5 is repeated 2 times. So 2 values are 5 and 1 value is -2, 1 value is 3. Total are 4 values. Okay, so in this way you can find the eigenvalues. If you want to find out the eigenvectors, then you will use eigenvect function. This function will be used for the eigenvectors, and this will return all the eigenvectors. See here, we can easily execute this statement, and you can find here all the eigenvectors. So corresponding to -2, we have this eigenvector. This is the first, and corresponding to the eigenvalue 3, we have this eigenvector, and corresponding to 5 is algebraic multiplicity is 2. So this will return 2 eigenvectors. This is the first eigenvector, and this is the second eigenvector. The same we can check in the SymPy. Copy from this place and use here. Okay, and then enter. So you can see these are the eigenvalues. Again, for the eigenvector, we can copy this statement, m dot eigenvector, copy and paste here, then enter. So you can see at this place -2, and corresponding to this one we have is one vector. 3 is also algebraic multiplicity is 1. So there is one vector, and for 5 is algebraic multiplicity is 2. There are 2 eigenvectors, and in this way you can use this statement to find out eigenvalues and eigenvector. Now at the end we have we can have diagonalize a matrix by using some statement, and we are using this diagonalize function, and this will return diagonalize is a tuple PD. D will be the diagonal matrix, and M will be equal to PDP inverse. This is the if we have a P matrix, and when you will apply this operation PDP inverse, this will be equal to the given matrix M, and we will verify this also. See here, we have this matrix, and we are using here P comma D is equal to M dot diagonalize. So this will return the P matrix, and the element of P we have, you can see at this place. This is the P matrix, and if you want to check the element of D, then this will return the diagonalization of the matrix. Okay, and if you want to verify by using here logical statement, we will use here P product D product P inverse double equal means this is the logical statement and is equal to M. If this logical statement will be true, then the values which we find at this place are valid, and you can see that when we execute this statement, this statement is true. So the verification is also has been done. The right hand side of this statement is equal to M matrix. So you will have 2 matrices. One is P and second is D. D is the diagonalization of the given matrix, and when you will apply this operation on the right hand side, this will be equal to M. So the basic properties of the matrix must be very clear mathematically, and only then you can execute all the basic operations by using this collaboratory in Colab. Okay, so here we discuss some basic operations of matrix, and the most important thing is that all the basic algebraic operations of and properties of matrix must be very clear. Only then this syntax will be very helpful, and simply you can use for all type of computing, which will be very helpful for data science, machine learning, deep learning, data analytics, and many more. Thank you very much to see this lecture till the end.